This is section 1.5, part B, parent functions and transformations. Your I can statements for this section. I can identify and graph and describe parent functions, and I can identify and graph transformations of parent functions. A dilation is a non-rigid transformation that has the effects of compressing, which is shrinking, or expanding, which is enlarging, the graph of a function vertically or horizontally. We have a vertical dilation if you have a positive value a that you're multiplying by your entire function, so it's out in front of the parent function. We know the graph is going to be expanded vertically if the value of a is greater than 1, and it's going to be compressed vertically if a is between 0 and 1. These values always have to be positive. If it's negative, it just means you're reflecting it across an axis, but the value a itself will always be positive. So if we take a look at this example, we're going to identify the parent function, we're going to describe how the graphs are related, and then we're going to graph f of x and g of x on the same axis. So let's go ahead and graph first. We're going to do a scale on the y-axis first. Okay, so if we just put in values for x cubed, we'll start at 0, 0. 1 cubed is 1. Negative 1 cubed will give us negative 1. 2 cubed will give us 8, which is all the way up here somewhere. So our graph is going to go up very quickly, and it's going to go down very quickly. Now, we want to take this and we're going to multiply it by 1/4. If you notice, this is out in front of the entire function. It's not just attached to the x, so it's in front of the entire thing. That means it is vertically. Now you have to decide if it's between 0 and 1 or greater than 1. 1/4 is between 0 and 1, so that means it is compressed vertically. And we're compressing it vertically by 1/4. So now if we graph our new function, we have 1 cubed, which is 1, and if we multiply that by 1/4, that'll take us down to 1/4. Negative 1 cubed is negative 1 times 1/4 is 1/4. 2 cubed is 8, and 8 times 1/4 will give us 2. And negative 2 on the other side. So this graph will look like this. We're taking it vertically, and this point is compressing down to here. The point all the way up here is compressing down to 2. We're compressing it vertically down. A horizontal dilation, again, we're going to use the value a, but this time a is going to be multiplied by just the x, so it is inside the function itself. This actually switches our compression and expansion. If it is greater than 1, you are going to compress horizontally. If it's between 0 and 1, you are going to expand horizontally. So if we take a look at this function, we have negative 0.2x squared. Our parent function is just going to be the square function. So if we start here, let's do our scale first. We are at 1, 2, 3, 4. So our original function, 1 squared is 1, negative 1 squared is still 1, 2 squared is 4, negative 2 squared gives us 4. So our original function looks like this. If you notice that 0.2 is just on the x, so that means this is going to be horizontal, and these are backwards, so since this is between 0 and 1, this is expanding horizontally by 0.2. We also have a negative sign out front. The negative sign is out in front of the entire function, not just the x. So that means we are reflecting it across the x-axis. Again, we had to identify our parent function. So our parent function is just x squared. So if we graph our new one, we're going to flip it across the x-axis, and we're going to expand it horizontally by 0.2. So 0.2 times 1 is 0.2. Squared gives us 0.4. But we're going to flip that across the x-axis. So we're going to be about here and about here. 0.2 times 2 is 0.4. Squared gives us 0.16. So we are expanding it horizontally, and it's going across the x-axis. When you're graphing piecewise functions, you just need to graph each piece separately and make sure that it has the correct shape. So we're going to find the values where they give us our x's. We first have an x value where x is less than negative 1. So we're going to plug that into its function. So if we do 3 times negative 1 squared, negative 1 squared is going to give us a positive 1. And 3 times 1 gives us 3. So at the point of x is negative 1, we have a y value of 3. And this is going to be all the values to the left of negative 1. If you think of an x squared function, it goes up to the right and up to the left. So we just need to have the correct shape. When we're between, that should be an open circle, because that is just x is less than negative 1. When x is equal to or greater than negative 1, all the way up to 4, we just have a constant function of negative 1. So we're going to go down to negative 1, negative 1. That's going to be a closed circle because it does have that equal to sign. It's a constant function until we get over to 4. And then it will be an open circle because it is just less than 4. When we get to the value of 4, now we need to substitute it into the last part of our function. So we have 4 minus 3 cubed. Sorry, that's 4 minus 5 cubed. 4 minus 5 gives us negative 1. Negative 1 cubed is still negative 1. And negative 1 plus 2 gives us 1. So if we go over to where x is 4, we go to a positive 1, we're going to have a closed circle there. This is to the third power, or its cubed function, and that goes up to the right and down to the left. Since we only care about to the right of the function, it will go up to the right. The last thing we're going to cover this section is transformations with absolute values. If your absolute value is around the entire function, that means all your y values are going to become positive. So anything that's below the x-axis will be reflected and be above the x-axis. If the absolute value is just on the x, that means we only have positive x values. So everything to the left of the x-axis you erase, and you mirror what was on the right over to the left. So if we first graph the function of x cubed minus 4x, the function should look like this. On the first one, we're going to find the absolute value of the entire function. So that means anything that's below the below the x-axis, we flip and put above the x-axis. So this piece on the bottom is going to become up here. This is above the x-axis, so it stays the same. This is above the x-axis, so it stays the same. And then that last part, since it's below, it flips up and comes up here. So everything down here then gets erased. On the second one, we are just finding the absolute value of the x. So anything that is to the left of the x-axis gets erased. Then whatever's on the right side, you reflect over to the left side. You just make the mirror image of it. And that would be your graph.